Okay, good evening, everybody. This is the last paper of today and this conference. Well, I'm Kaili Wang from KU Leuven, Belgium, and the co-authors are Huang, Yu-hui, Jose Oramas, Luc Van Hu, and Tinne Tuytelaars. And this paper is an analysis of human-centered geolocation. Well, image geolocation is an interesting topic, but right now most of the work is based on background, like analyze buildings architecture or some artificial landmarks, like Eiffel Tower or Atomium. And in this paper, we don't consider this type of images anymore. What we used are the human-centered images, like this. Well, we try to do the geolocation using these human-centered images because online social networks like Instagram, Facebook contain a constantly increasing amount of this kind of images, and we want to figure out whether the features extracted from human or some background could be used for geolocation. And to the best of our knowledge, this is the first work to addressing the visual geolocation problem from a human-centered perspective. Well, we propose two research questions. Is it possible to geolocate a human-centered image? If so, what are the useful visual cues for geolocation based on human-centered images? Well, we treat this task as a classification problem, and we use three methods. And for visualization, we upsample the activation map of the last convolutional layer. Well, for the dataset, we use three different datasets. Two of them consists of 12 cities, and the third one consists of 164 cities. The first experiment we did is human study, and the purpose of this experiment is to know how difficult the task is. We let people to do an online survey and selected 1 out of 12 cities where they think the human-centered images was taken, and you can see the result. For the people without training, the performance is only about 12%, and for the people with training, which means we show some example images before they did the survey, their performance doubled. And for the random case, it is only 8.33%. The second experiment is automatic geolocation using CNN, and we can say the fine-tuning works best, and the result shows that this task can be solved by an automatic method because the best result is much better than human performance. Then we want to take a closer look, so we use faster RCNN to detect the bounding boxes of the person in the image and only use the part within the bounding box. Well, the result shows fine-tuning still works best, and you can observe that there is a 5% loss compared with full image feature pooling. Well, here we compare the classification with retrieval. For the retrieval, we use fine-tuned CNN to extract the features from both training and testing datasets, and then measure the distance. The blue bar is classification, while the orange bar is retrieval, except the image from Pinterest. The classification works better than retrieval method. Here we consider a larger dataset which consists of 164 cities. The result is quite good. It is because now some cities are quite remote, and the number of users uploading images from those locations is significantly smaller. So even when additional classes are added, classifying this is a simpler problem. Well, at the left, I will show the features learned by the neural network. At the left, these features are centered in the foreground, which means the human region, and you can observe they are located in the arms, legs, or upper bodies and faces. And for the right part, these features are distributed among the background, like trees, grass, and walls. Well, all the 5-twin CNN models are released on my personal website, so you can download them. Yeah, thank you. And you can come to my poster for more.